So this is page 134, tutorial 3.6 in your textbook. Confidence intervals. Okay. Now, quite often, you'll hear it on the radio, you'll see it in the newspaper, whatnot. They'll do a survey. Many surveys and polls are conducted to estimate the opinions and preferences of the general public. A good report on a survey gives the results along with an indication of their accuracy, because there's no point doing a survey unless you know how accurate that survey is. Now, here's a quick question. When they do like a survey to see who's, like let's say we're having a federal election, we're electing a new government, a new prime minister. How many people roughly are there that are eligible to vote in Canada, do you think? Like, first of all, what's the population of Canada?
6 million.
No, it's way more than 2 million. I think it's upwards around 30 million or so.
36.
Okay. How many?
Out of California.
Is that right?
California is 4 million.
Really? Okay. So of the approximately 30 million people in Canada, how many people do you think are actually old enough to vote? What do you think?
Probably 20. So.
Probably 20, maybe. Well, for rough figures, let's say 25 million. Okay? We'll just guess 25 million people in Canada that are eligible to vote. So when they do a survey to see who's going to be the next prime minister, like ahead of the election, how many people do you think they actually survey? Like how many people do they phone to ask their opinion?
A million.
A million? How long would a 10? 10 million or 10? Who, I don't know who said that. Was it Luke throwing his voice? Oh. Well, okay, so we'll go with a million. Do you think a million's too many people?
Yes.
Seems like an awful lot of people, doesn't it?
10 people from each province.
10 people from each province? You're a little on the low side. Usually it's in the area of about 2,000 people across Canada. 2,000 people out of about 25 million is accurate to within plus or minus, I think, about 3%. Okay, so you don't need to survey everyone. In fact, there was a survey many years ago. I spent a little more time with it a few years back. There was a group in Dauphin. This was before that they outlawed smoking in public places like restaurants and bars and stuff.
Biggest mistake.
Okay, so anyways, there was a group in Dauphin that actually did a survey and presented it to town council saying that they wanted council to enact a law prohibiting smoking in restaurants. And town council actually said you didn't talk to enough people because you only called every 10th person in Dauphin. So obviously town council knew nothing about statistics because 1 in 10 is actually overkill. You don't need that many people. If they interviewed 100 people in Dauphin, would have been enough. Would have been accurate within about 2 or 3%. So anyways, okay, we're talking about accuracy.
What if you get a bunch of one-sided people?
You have to make
What if you go to the church?
You have to make sure that you pick your people randomly. And what they did was they picked every 10th person in the phone book, which is completely random.
Yeah, but for chance, they could all be steered towards.
By chance, but statistics will tell you highly unlikely. Highly unlikely. Okay, so what I'm going to do here is I'm just going to read this excerpt from the Vancouver Sun. Keep in mind this is 12 years old. Well, Canadians are gravitating toward the internet. Hey, yeah, see, 12 years old. They don't trust it as a source of information. Internet chat rooms score the lowest of all credibility. Independent websites fare better, but still lag as a credible source. With only 14% of those surveyed viewing them as very credible. Another 37% said they were somewhat credible. The survey of 1,613 Canadians was conducted over 10 days in late April and is considered accurate to within 3.1%, 19 times out of 20. Okay, so this is the important part right here. Okay, guys, enough.
I'm trying to fix my mind.
Okay, we'll fix it later. Okay? This is what's important. So there was 1,613 Canadians. It's accurate within plus or minus 3.1%, 19 times out of 20. 19 times out of 20. So what that means is, if the survey were conducted 20 times, if you were to do the same survey 20 times with a different group of people, 19 of those times the results would be 14%, right? Because that was the result. 14% of people said they found the internet websites as credible. 19 times out of those 20 surveys, the actual answer would be 14% plus or minus 3.1. In other words, it would be some surveys would be 13%, some surveys would be 15%, but in 19 out of 20 cases, it would be within, let's say it's 3%, it would be between 11 and 17. That's how accurate it is. There would be one survey, 1 out of those 20, that would actually be outside that range. Would it be like 47% instead of 14? Would it be that much outside the range? Could be, but extremely unlikely. It would likely be only maybe 14%, maybe plus 4%. Okay, that's just the way surveys work. So this is what we're talking about today. This plus or minus 3.1% and the 19 times out of 20. That's what we're talking about. That's known as a confidence interval. And I'm going to keep reading here in the textbook. Okay? I'm going to skip down a page here. Actually, the 19 times out of 20 is important because 19 out of 20, if you do that as a percent, is equal to 95%. The most common confidence interval is the 95% confidence interval. Okay? 19 times out of 20 is what you always see in the reports, but it's actually called the 95% confidence interval. So it says in the book, the interval 14% plus or minus 3.1% is called the 95% confidence interval. Now, what do I have here? Let me just see. Yeah, here it is here. The interval 14% plus or minus 3.1% is called the 95% confidence interval. How did they come up with those numbers? And that's what I'm going to show you today. How do you come up with a 95% confidence interval? The exam questions are going to say that. Construct a 95% confidence interval. It's actually fairly easy. I can make it complicated if you want, or I can make it easy if you want. I choose to make it easy. Okay? So it says in tutorials 3.3 and 3.4, you work with this 68, 95, 99% rule. So you might remember that the 68, 95, 99% rule said that about 2 standard deviations covers 95%. It's not exactly 2. Okay, so I'm going to give you the exact number right away. Okay, so to calculate the 95% confidence interval, this is the formula that you're going to use. You're going to take the mean, and you should jot this down in the space on your sheet. You're going to take the mean, and you're going to add 1.96 standard deviations. That's the formula. There is a way to do it on the calculator. It's far more complicated than it needs to be. Okay? It's plus or minus 1.96, yes. Okay, plus or minus 1.96 standard deviations. Now, on the rarest of occasions, the people at the exam committee say, you know what, we've been doing 95% confidence interval for quite a few years. Let's change it up a bit. So you need these formulas as well. Okay? There are other intervals. There's the 99% confidence interval, and there's the 90% confidence interval. Now,
I don't get that sign. I didn't write that down.
the plus or minus,
That one.
it means you take the average, you add 1.96 standard deviations, and then you subtract 1.96 standard deviations. Okay? You're finding the low and the high boundary is what you're doing. Okay. Now, if you want, I'm just going to draw a picture here. Okay. Here's my average. I'm minus 1.96 and plus 1.96. In fact, what you do is if you shade normed between minus 1.96 and plus 1.96, you would get a shaded region of 95%. That's what it means. That's what it really means. Okay? If you shade norm between minus 1.96 and plus 1.96, you'd get a shaded area of 95%. Now, if you wanted to be more sure of your range, if you wanted to say, you know what, 95% isn't enough confidence. I want to be more confident. I want to be 99% confident. Would you make the range wider? Would you make the target bigger? Or would you make the target smaller? Make it smaller? Make it bigger. If you're trying to, if a little kid, let's say there's a little kid, they're doing like a beanbag toss or something, and they're tossing beanbags into like a can, right? Or a recycling box or something like that. To make it better for the little kid, to make them more successful, 99% more successful, would you give them a bigger target or would you give them a smaller target?
Smaller.
A little kid. If you want them to be sure to get it in the box, you would give them a bigger target. So, Stashko, now that you know that it's a bigger target, am I going to make it wider or am I going to make it narrower?
Narrow.
I think he's just doing that on purpose, am I right?
No,
Actually, I'm hoping.
last time was not.
Yeah. All right, so if I'm going to make it wider, it's going to have to be more than 1.96. So the rule for 99% confidence interval is mu plus or minus 2.58 standard deviation. 2.58. You make the target wider. The problem with that is that now that you've made it wider, so now you're going to say instead of plus or minus 3, you're going to say like something like plus or minus 5%. And now people start going, whoa, that's a pretty wide range. What's going on? Right? So, well, if you want to make it smaller, if you want to make the range smaller, then you have to be less confident, like about a 90% confidence interval. Well, that's true. So plus or minus 1.64 standard deviations. Okay, so those are the rules. They work exactly the same way. If I say 95% confidence interval, you use the 1.96. If I say 90%, you use the 1.64, and so on. Okay, it's all balanced. If you want to be really, really confident, you got to make a bigger target, and then people start going, whoa, hang on. But if you want to be really, you know, a small target, well, then your confidence interval goes down, your confidence level. So the 95 is the most common because it's sort of in between. It balances the two, kind of thing. Okay?
Can you go lower than that?
Oh yeah, you could have like 100%. Well, you can't have 100% confidence interval. You can never be 100% confident. But you could have a 99.7%, and it would just be really, really wide. That's all. Okay, so what the heck am I talking about here? Let's go over to example 1. Let's give you an example here to sort of figure out what the heck we're talking about here. Okay? Oddly enough, the student council here at the DR is having a dance, I believe, tomorrow night. They need 110 tickets to break even.
They didn't get that.
Just an example. You know that 10% of students attend dances, and this year there are 1,350 students in the school. Now, the best part about this, Rowan, put the phone away. The best part about this one is you always know what the question is, because they're going to say, construct a 95% confidence interval. There's no way to say, I don't know what kind of question this is, because it's going to say confidence interval in the question. So, how do we do that? Okay, Stashko, I need you to listen. Someone was calling me. Who was it? Okay.
Speakers in District Freezing room.
Yeah, thank you. Okay, so the 95% confidence interval is mu plus or minus 1.96 sigma. Do I have the average?
Yes. No.
Does it say mean or average anywhere in the question? Does it say standard deviation anywhere in the question?
No.
It does not. How do you come up with them? What do we know? Let's just move this aside for the time being. We know they need 110 tickets. Are we going to use that in the question?
No.
We're going to compare our answer to 110, aren't we?
Right.
What's the what is the 10%? Sorry, what does the 10% stand for?
The average. C-score, cross-score. Yeah.
It's a percentage. If you randomly picked a kid in the hallway, if you randomly picked a kid in the hallway, there'd be a 10% chance of you picking someone who was successfully going to the dance. So your p-value is, did you say that, Brandon? Your p-value? Probability? Your p-value is 0.1, which means your q-value is how much? 90%. Very good. How do we get mu and all that out of p and q? What's my n, by the way?
Why is it negative? What's n?
It's not negative 9. That's a decimal.
Oh, yeah.
What would n be?
1350.
Yep, n is 1350. Okay?
It's PQ or it's NP that makes mu.
N and p make mu, that's right. So mu equals n times p, 1350 times 10%. You would average 135 kids at the dance. That makes sense. There's 1,350 kids. 10% of kids go to the dance. How many kids go to the dance? 135. But that's on average. That's the average. Now, just based on that, just based on that, are they going to sell 110 tickets? Absolutely, right? But that's the average. Sometimes it's less, sometimes it's more. We need to construct a 95% confidence interval. So now I go sigma equals square root NPQ. So that's going to be 1350 times 0.10 times 0.90. So you're coming up with the standard deviation. And in this case here, it's 11.02. 11.02 people. Okay, so that's my standard deviation. All right, how do I get my 95% confidence interval? Easy. I take this formula right here, and I just apply it. What's my mu value? 1350 plus, it's on this side, 1.96 times 11.02. Okay, so now I've got 135 plus or minus 21.6. Okay, and if you're following along on page 136, you know that then you go 135 minus 21.6, and you go 135 plus 21.6. And you get an interval of, and if you round off to the whole nearest number of people, because you can't have a half a person, you get 113 to 157. That is our range. 100, but we're 95%. This is our 95% confidence interval. I am 95% sure that between 113 and 157 people will.
So they're 95% sure that they will break.
Actually, they're more than that because they need 110 to break even. So by going to 110, you're actually increasing that confidence level. So they're 95% sure they're going to get at least 113 people, which means there's about a 97, 98% chance they're going to break even, right? It's a pretty good chance. Okay? It's based on statistics, and people actually do this for a living. People do this. Well, because I know everyone always says, "When am I ever going to use this? I'll never use that in my life." Well, you don't know what your life's going to entail, so. But people actually do stuff. Okay? Hard or easy? What do you think?
Basically the same.
It's basically more of the same, isn't it?
If you ever teach you all formulas, that should be.
It's more of the same. Okay? You're doing you find your P, Q, and N, you do your mu, you do your standard deviation, and then you just apply that formula. I am 95% sure that if this question appears on the exam, they will say, construct their 95% confidence interval and explain what it means. There's always a mark or explain what it means. All you have to say is, I am 95% sure that between this value and that value will whatever. That's all you got to say to get the mark. No, you have to say, I'm 95% sure. You can't just put whatever.
Thank you. Cool.
Okay, now, there's also a little bit more here.
What was the 99%?
The 99 was 2.5, 2.58. Yeah.
2.5.
Okay. A couple of quick definitions here. The 21.6, in this case here, the 21.6 is called
Where do we write this?
wherever you want. Oh, hang on. What's on my next screen? Yeah, the margin of error. You already wrote it down. The margin of error is, you've already got it. The margin of error is the amount that is to be added to the mean to construct the confidence interval. It's plus or minus 1.96 standard deviations. The margin of error is how much you add and subtract. And in this case here, the example, it was 21.6 people. That's called the margin of error. How much you're allowed to be out on the positive side, how much you're out to be allowed on the negative side. If they ask you for the percent margin of error, and you don't have this on a sheet anywhere, percent margin of error, And be really careful. Read it, Rick, read the question carefully, because if it says margin of error, you just take the 1.96 times the standard deviation. If it says percent margin of error, you take the 1.96 standard deviations and you divide by n. In our example, it would be 21.6 people out of 1350, and you express that as a percent, and it's plus or minus 1.6%. You just take the margin of error and divide by n. That's all you do. It could be, yes. I would emphasize that I'm asking for the percent margin of error. Okay? And Luke's right. If you've got a cheat sheet with the formulas, you gotta know when to apply the formulas and how to do it, really. Okay? How are we doing for time? Okay, here's a question here. It's in the book. I would recommend that you not look in the book. Why don't you try this one right on the sheet? Try that question right on the sheet, and I'll join you in about 3 minutes, and we'll work through it together. This is it says construct a 95% confidence interval for the percent of people that need corrective lenses.
Everything we just did and add this step.
Sort of. Part A is a little bit different.
Why would you do that?
I didn't. Okay.
I'm not done.
That's okay. Did you get this far?
Is there a recycling? Yes.
Yeah. Did you read it? Okay.
I got the six.
Did you get N is 200, P is 55, Q is 45? Keeper, did you get that? Yeah. Did you get a mu value of 110? Did you get a standard deviation of 7.04?
No.
Even if you don't know how to do the confidence interval, you can probably do that, get some marks. Go.
Oh, I've got a square root here.
Okay, so what's the next step, Rowan? Next step is to go mu plus or minus 1.96 sigma. Write the formula. So that's 110 plus or minus 1.96 times 7.04.
Equals 13.79.
13.79?
Yes.
Can we say 13.8?
Yes.
Okay, so the 13.8, just so you know, that's referred to as the margin of error. I still have to actually add and subtract 13.8. So when you do that, you should get 110 minus 13.8 gives you, they just say 96. 110 plus 13.8 gives you 124. Okay, so this is my 95% confidence interval, but it's 96 people and 124 people. We're 95% sure that between 96 and 124 people are going to need glasses.
Now, I asked at the very start of this question if it was going to be exactly the same with an extra step to it.
You're right.
And you totally lied, man.
No, because I'm not actually done. No, there's actually more to Part A. Because Part A asks for the percent of people that need corrective lenses. Percent of people. So they're throwing you a curveball here, which I would not do. I would not do this. This is kind of stinky. You take 96 people out of 200, and you get 48%. And you take 124 people out of 200, and you get 62%. No, I wouldn't ask this, but I just need to explain it because it shows it in the book. This is the 95% confidence interval for the percent of people.
So there will be no percent margin of error question on this.
No. I better double check.
Yeah, I know, please, so I don't copy it down.
Yeah. I won't do it. Because I've made the test up already. If I've done that, I'll just say, we'll fix it. Okay? But I just want to point out, and I can't ever see them doing this on the exam, but that's what they mean. They want, the question said the percent interval.
It's not really hard to do this.
No, I know. It's just like, yeah, it's a trick. It's not fair. I agree. It's not fair. Okay. What about the percent margin of error? The percent margin of error is your margin of error, 13.8 people, divided by 200 as a percent. That's your percent margin of error, plus or minus 3.1. Oops. Plus or minus 3.1%. So this is the percent margin of error.
So there's really just two different things. Right?
Yeah. And really, if you have to focus on one thing, focus on doing up to here. That the percent margin. This is B right here. Yeah.
Oh, I didn't get
That's B right there.
So what do you
the same thing.
Oh, you just take the.
You just take the margin of error and divide by the end. That's all.
What is it? The margin
Yep.
error and then.
Did I do something wrong?
Yeah,
Yeah, it needs to have standard deviation.
I thought that's what the other.
Oh, I did C, 6.9%. Thank you. I'm looking farther down. I looked at the wrong answer. Thank you, ladies. $6.9%. All right. I have got an early Easter present for you.
No test Wednesday.
Not quite that extreme, Steve.
What's Easter?
I've got an early Christmas present for you. First of all,
Christmas announcement.
did I say Christmas? Christmas, Easter, Groundhog Day, whatever. St. Patrick's Day. First of all, yesterday I gave you a bit of a review. Right? Here's that same review with all the answers to that for you. Okay? You have the questions. Here's the solutions. I spent half an hour doing them for you.
Right, so you mean, is that the lunchtime club?
The lunchtime club
With the answers?
with the answers.
Oh, so you can like this.
That's what I need. Now, here's what I'm going to do for you today. This is a last time I'm ever teaching this special bonus. If I don't have to talk to Stashko more than once between now and the bell, here's what I'm willing to hand out. Okay. And yes, it's bribery, by the way. Here's what I'm willing to hand out. I have right here, or somewhere here.
I request the use of physical force.
I have right here a copy of the test, which I will give to you at the end of this period.
If you don't have to talk.
If I don't have to talk more than once to Stashko to get this.
Can I go to the bathroom?
You can't wait till after school to do that.
No, I just like you to sit in class and do some work.
Take it on. Do we get to take it home?
You get to take it home, Rowan. There's two catches.
Stephen can't talk.
Well, that's the one. The two catches are this. There are a few multiple choice questions that I've removed, because that seems a little bit unfair.
Yeah.
And the second part is all the numbers tomorrow will be different.
Okay.
Okay? As for example, a group of students are surveyed as how many hours they work part-time a week. The hours here are 8, 9, 5, 10, 10, and 8. Tomorrow they'll be different. The question will be identical.
I just be taking out numbers.
You can write your formulas in order with every question.
Number one.
You don't get it until.
What do you
A
mean?
minute
What
for
do you
the-
jump as a question?
Oh, yeah, and actually the questions are jumbled. That's right. I did jump. I did rotate the questions.
Well, that kind of makes useless stuff.
I'm giving you the test, man.
That's alright. I like it.
Okay? You shut your mouth. We'll just see if Stashko can work.
I can get a drink of water.
Please do.
Are we done with this?
I'm done. Not my friends and stats.
I want to hold you on that.